Hello viewers, hello everyone. Myself Yashoda. In last I have 5 years of experience in teaching physics. In this video, I'll try to explain the concept called momentum and how it is related to Newton's second law of motion and how we're going to derive the Newton's second law formula using the momentum we're going to discuss here. Let us see. Just a second. Here you can observe what is the momentum factor. Here you can observe the bicycle of first having a small mass, and you can observe your truck which will having a more mass, right children? Definitely from cycle compared to truck, mass will of the truck will be more. So when they having a more mass like this, which will come first because they're of the same height, imagine same potential energy they are from here. Okay, then which will reaches the ground earlier, you have to think. Okay, so answer of this question at the end of this video, you only can guess it, you can answer this. Okay, let us see what is the momentum concept, children. I'll just take a screen to explain it better. So momentum is given by mass into velocity or momentum. The word momentum only indicates that quantity of motion. Quantity of motion. How much body will move? How can body will move? The quantity of motion is given by the momentum. It is represented using a symbol called P. It's given by product of mass into velocity. Right, children? Momentum is given by product of mass and velocity. Okay, suppose a body is not moving. When the body is at a rest position, its momentum will be zero. Because why? When a body is at rest, its velocity is zero. So that body's momentum will be zero. Suppose when the body is moving, okay, what velocity it is moving and how much body will have. Let us take this body having a mass of 2 kg. It is moving with a velocity of 2 meters per second. Okay, in that condition, the body having a momentum of 2 into 2 mass into velocity, it is 4 kg per meter per second. This is the momentum of the body. Understood? If the body is at rest, no momentum. When the body starts moving, okay, in that condition, body will have the momentum. Right, children? So momentum is clear to you. Momentum is in everyday life. We can able to see the momentum. Whenever the objects are moving along a translatory motion, you observe the momentum. Momentum actually we can consider linear and angular, but object is in a translatory motion. We cannot consider angular. When the body is rotatory motion, in that we consider angular momentum L. But here we just see only linear momentum. Right, children? Momentum. The SI unit is mass is kgs and the velocity is given by meter per second. So that is what the SI unit of momentum and the dimension formula of momentum you want to write dimension formula writing any time, you just put MLT all the time. Okay, and see the powers of this: n power of 1, L power of 1, T power of -1. Okay, this is what the dimension formula of momentum. Right, children? And see, since velocity is a vector quantity, it is dependent upon direction, right? So that momentum is also the vector quantity. Since mass is the scalar and momentum is depend directly on velocity, so it is a vector quantity. Right, children? Momentum is which quantity? It is a vector quantity. This is regarding the idea of momentum. Let us see if a body having, okay, let us take body a big, small and a small body having a given that momentum will be equal. Both the momentums are equal. In that condition, 10 kg, let us take 20 kg, which will have moving with a high velocity and which will have having a move with low velocity. So you can find, because the given momentums are equal. So P1 V1 is equals to, right, children, P2 P2 you can take. So here P1 given has, okay, sorry, not P1. P1 equals to P2 means M1 equals to M2 and M2 V2. Okay, M1 V1 equals to M2 V2 we take, and M1 is given as 10 kg. Velocity we need to find, and M2 is how much? It is a 20 kg velocity V2. Understood? Since it is momentums are equal, so we're going to take this idea. So now you want to find the velocity of first body, a second body. Ratio of the velocities means V1 by V2 is equals to, children, 10 and this 2 cancel. So why you remaining only 2 here? Okay, that means V1 is moving with a velocity of 2 times the greater than the V2. Understood? So V1 will be the fast and V2 will be the slow. So how we are going to decide this fast and slow? based on the momentum idea. I hope this is clear, children. So how you going to compare the momentum of the two bodies? By mass and their velocity. Suppose think one more problem that if both the bodies are going with the same velocities, okay, it is also moving the 2 meters per second, it is also moving the 2 meters per second, both having the same velocities. In that condition, which will have more, okay, if momentum provided is equal, and which will have more mass now? Yes, can you guess, children? Both having the same momentum, same velocity also. So, which will having, now momentums are equal, we can write P1 equals to P2, right? And M1, V1 is equals to M2, V2. Since V1 and V2 are equal, so that cancels, right? Okay, if it cancels, both will be having same velocity in that condition. Okay. So, this is how you're going to think the problems regarding the linear momentum. So let us see now how this linear momentum will be depending on the second equations of motion. So that is also just discussed. See, just a second, children. Momentum we can write it as P is equals to M into V. Let us take one ball having a momentum P1. I throw ball on the wall. Okay. So what will happen? It will rebounces because the elastic version also, it will rebounces with the same speed. Imagine this is V minus, it will rebounces with the same speed. In that condition, its momentum is P2, imagine. And the mass of the body, since the body moves with whatever the speed, mass of the ball never changes. Okay, when it is provided in the elastic version, in that condition, I can take P1 and P2. Okay, P1 is initial momentum, P2 is the final momentum. In that condition, I can write a change in momentum. Change in momentum. Change in momentum is given by delta P. The word delta is change in. Momentum is given by final momentum minus a initial momentum. Imagine initial momentum of the body we can write M into V, and the final momentum we can write it as M into U. Where mass is same, final momentum V, final velocity, U is the initial velocity. This is final velocity we are going to take. It's the initial velocity. Right, children? So this is what the change in momentum. But the any term we're going to compare with the rate of change of momentum. Rate of change of momentum is given by delta P by T. Rate of change of momentum is given by delta P by T. Because anything, suppose rate of change of velocity gives you acceleration. Similarly, rate of change of momentum also gives you one factor. How to find this rate of change of momentum? See, M into V minus M into U divided by T, or we can write this M into V minus U. Since mass is same, I'll take it as M into V by T. You can observe here, no? Acceleration is not, children, acceleration is V minus U by T. So in place of V minus U by T, just I'm going to replace M into acceleration. Right, children? Mass into acceleration I can replace. And see, one term you observe, children, the force acting on the body is directly proportional to the rate of change of momentum. Okay, the force acting on the body is directly proportional to rate of change of momentum. This is what the Newton's second law state, and this is all, it is proportional to what? So rate of change of momentum by time, what you will get, children, is mass into acceleration, right? Mass into acceleration. Or we can write this force proportionality symbol in a physics. We can remove proportionality and we'll put some, replace with some constant. Here also proportionality symbol replace with the constant K, where how to get the K value of K means when F by M into A, when force of 1 Newton acting on the body of 1 kg body of moving with an acceleration of 1 meter per second square. See, 1 by 1 into 1, how much, children? It is getting 1 only. So if the K value is 1, when body moves with a force of 1 Newton applied on a 1 kg body moves with an acceleration of 1 meters per second square, in that condition you will get K value as well. So this is proportional. In that condition only you will get F is equals to M into A. This is what the Newton's second law. We are deriving the idea of momentum. I hope that you are, children. So momentum and Newton's second law related by P, F is equals to, suppose momentum is equals to F into T, we can write. Okay, change in momentum is force into time or mass into acceleration. Both the formulas we going to remember from this derivation. I hope clear, children. So that is why we can write one more unit of the momentum as Newton second, where Newton is a force, unit of force is Newton and the unit of time is seconds. So like this we can define the momentum one more unit of fluid. Let us see now unbalanced forces. The concept of unbalanced force is very important in physics because our block is there. Suppose you playing with a tug of war, both the sides you are applying the same amount of force, right children? So what will happen? Net force here. That means difference of force. Body is not moving, right? Acceleration is zero in this condition because both the sides equal force applying to, so 2 minus 2 gives us a 0. Suppose when block is there, children, you are applying one side it is a 3 Newton and from other end only 1 Newton you applied. In that condition, what you will get, a net forces equals to 3 minus 1 you will get as a 2 Newtons. Here this 2 Newtons is not equals to 0. So this is what the condition of unbalanced force. Both the side the force is not balanced, like your tug of war. If both the sides equal persons are pulling, the thread not move anywhere. But if one side is a more persons, one per side only one person, that time the body will just accelerate in the more force direction. Okay, the body will have acceleration. When the body will have acceleration, that will entirely depend upon two factors. One is it will be depend upon net force. Suppose how much force I am applying. If I apply 5 newtons of force, acceleration will be more. If I apply less amount of force, so acceleration is directly proportional to the force. Understood children? And next, acceleration is inversely proportional to the mass. If more mass is there, so it's very difficult to move. So I'll just clear this concept with some example to you. Yeah, let us see this figure. Acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. How it is seen from the figure, if a mass is there in the first case and the second case, you can observe in the first case mass is less, in the second case mass is more. Okay, because of more mass, force is same. Because of more mass, here acceleration will be less and here the acceleration will be more and the speed increases. Because why? Mass is less. So that acceleration is inversely proportional to mass. We can conclude this, right children? Okay, next figure you can see here. The mass is same. Okay, only thing of force. If I apply the more force, body going with the more acceleration. Here, see, if I apply more force, body is going with a more acceleration. If I apply less force, body going with less acceleration. That means acceleration is directly proportional to the force, right? So from this, you just conclude acceleration is directly proportional to force and acceleration is directly inversely proportional to mass. So combine this, you can write acceleration is equals to force by mass. Okay children, this is what the Newton's second law. Okay, what Newton's second law says that children, according to Newton's second law, that according to Newton, what Newton says that an object will only accelerate if there is a net or unbalanced force acting upon it, right? The presence of unbalanced force will accelerate an object, changing its speed, direction, and both the speed and direction. Okay, this is what explained by Newton. So you can observe these figures, we can just easily conclude that here you can observe force is more. Okay, if a large force, large acceleration, the person and the boy, so definitely the person will apply more amount of force compared to the small boy, so force will be, acceleration will be more in second case. In the second one figure, you can observe mass is more, you put more weight in the second trolley, so that will be, acceleration will be less. Okay children? Yes. And this is a very important slide, you need to observe, concentrate more here. See, a change in momentum, right children, or a force is directly proportional to change in momentum by time or rate of change of momentum. That means inversely again time. So as the force increases, the time increases, the force going to decrease. So that is why here when the person going to catch a ball, okay, when the person need to catch a ball, he just pulling his hands backwards. Okay, after catching the ball, he just pulling his hands back. You can observe this figure clearly. The person is pulling, he is not catching. The first condition is just to catch like this. What happened? Time is that fastly he can catch the ball here. But here what happened? He's not fastly catching. He's pulling his hands back and catching the ball. So the time gap going to increases. You understood, no? Mass into velocity minus mass into u by t, but this entire term becomes 0 when you're going to catch, when you're going to catch, final velocity will be 0. So you will get only mass into velocity. What initial velocity is coming by time, it will come mass into initial velocity by time. So is the entire depend upon time. If you increase the time, definitely you will get the less pain. Or in this condition, first condition, you'll get a more pain because more force is acting on him. Okay, in the second condition, because as the time is increases, so you'll get a less pain because the force will be acting on his hand is less. I hope this clear, children. That means the force, that is why we're going to pull, the force increases. So not only in that condition, you can observe here, the airbag will going to open when the sudden accident will be happen. What is the use of this means, when you fall an airbag, just take the time to fall on the this wheel. Okay, so when the time increases, again time is inversely proportional to the force. As the time increases, force acting on his head will be decreased, so that you won't get so much damage when accident happen. The same time, the seat belt also providing. If suddenly brakes will happen, he will fall, he will get hurt. So seat belt is avoiding is to fall and increase the time gap. Okay, so that it will also helps. Understood, no? How it will be depending upon force and the time, change in momentum by time. I hope this is about the Newton's second law and how it is related to the factors. Okay, we understood. Let us conclude what we learned so far, children. Okay, I told you to, you can answer this question at the end. Okay, I think you can able to answer now, because here mass is less and here because of more mass it will possess the high velocity, and because it is the mass is less. Okay, it is a less. Just a second, children. Because of more mass, it will have more momentum. P equals to mass into velocity. They will directly depending upon momentum, right? So more momentum it will have, and it will be having less momentum. Okay, children. I hope this is clear. So let us take some examples to clear the concept better to you. Let us take a block of 1 kg and a block of 10 kg. Okay, provided both will having the same momentum. Then which will having a high speed and which will having a less speed. So how you going to compare the speed? By momentum. P1 is equals to P2 provided, where M1 is 1 kg V1 and it is having a 10 kg V2. So P1 is equals to 10 times of the V2. That means it will go with the slow speed and it will go with the high speed compared to V2 10 times more than it is moving. Right, children? This is how we are going to calculate momentum. So let's conclude all the formulas we learned. Mass into velocity we learned, and also see, children, kinetic energy also we can able to calculate. That will be equals to P square by 2m. Okay, this is a formula we can use to find kinetic energy, and force is proportional to the rate of change of momentum. Okay, or we can write delta P is equals to F into T. Change of momentum is force into time. Or also we can write F is equals to mass into acceleration. So all these terms we learn. So based on this, we'll easily solve the problems. Okay, children. Thanks for watching. Keep watching like this. Thank you all, children. Have a nice day.